Back in the dark ages of the World Wide Web, anytime you wanted to update anything on a web page, you had to go make a whole new web page. You had to go to the server and get a new one. It's not just like connecting and getting a web page. You have to go make a connection to the server. Server says, okay, we're connected. You have to go send a request to the server. Server sends back the data. Then you have to close a connection just to update anything on a web page. This is just depressing. Then somebody had the idea of XML HTTP requests. This was amazing. This is how Ajax worked. This is how Gmail was able to go look at your the list of who you might be sending emails to. This is how so many things on the web are made so much nicer. Now, once you have a connection and you get your web page, you can send things like just a T or an E without reloading the entire web page. But that's how it was till 2011, when the W3C came out with WebSockets. WebSockets are unbelievable. Now, you still have to do the whole thing to get the web page to begin with, but rather than making a whole new set of requests and doing all that work every time, when your web page loads, you connect to the server, say, hey, can I talk on a WebSocket? Server says, sure, why not? Now, whenever we want to say something like T and E, say we're auto-filling this box here, see how it says TE and test and T's, whatever. Now, you can say T, it sends you back some stuff, or E, and it sends you back some stuff. This is so much more efficient. You may be wondering how fast this WebSockets is. Well, in this case, it's running at around 500 Hertz. What that means is right here, when the website still has to go do this connection thing, it has to pull this website from the ESP8266. Once it does though, now anytime it says T and it gets a response, that can happen in as little as 2 or less milliseconds. That's just unbelievable. So some of the features that I've been able to add in this is something like an oscilloscope. As you can see, when I open up the oscilloscope, the speed slows down. This right here is using the ColorChord version of this system, but I've added this same system to the WS2812 I2S driver for the ESP8266 WS2812 I2S driver, which I covered in a previous video. So with ColorChord, we have a little ADC on the chip, and that little ADC right here is being displayed. So with WebSockets, I'm issuing a command. Let's just see what that would look like. A CM command. I'm going to submit it, and the ESP8266 responds with, unfortunately, I'm still not using the newer versions of WebSockets which allow you to respond with binary data, but still, it sends back all of the oscilloscope data for that frame. And it does this at around 200 Hertz. It means it sends it back and it is updating this canvas right here, this HTML canvas. So, if I go play a song, say this, it's off of Brendan Becker's, or Inverse Phases, Shuttle Scuttle OST album, you can now see in the browser in real time the information that's coming off of my audio port here and going into the ESP8266's ADC, being updated at, right here, 16 kilohertz. So now you can see the actual waveform inside the browser. Because this is running ColorChord, it has to do a DFT, folded, a regular DFT, which then it fuzzes and then it folds, and then based on that, it can decide on which notes it thinks are pertinent. So you can see here, see some moving around shortly. And from there, it decides on colors of setting a whole bunch of LEDs that it can use on its outputs. There's other things that this can do as well. So certain things like right here, I can take the system reflash and I could drop on new firmware, or I could just drop on a new web page. This is actually the same web page, but I can reload it. And you can even do something like, I have a little interface right here for controlling the GPIOs. So right here on the ESP8266 board this is my quadcopter dev board, I have a little LED right there. So I can click 5 and turn that little LED on or off. These are just some of the things that you can do. I've added a couple of this to the other project, and I'm adding it to my Wi-Flyer project. But you may be wondering, how does this operate under the hood? So under the hood, what's going on here is our JavaScript is running all the time. And there's this little loopback thing that's going. That's whenever it gets new oscope data, it just wants more oscope data. And that's what we were just looking at. So it calls this function that we wrote, QOperation, which takes on a plain text command like cm, and once it's done, it calls the function getOscope. It adds this to the work queue. The reason that we have a work queue is on the JavaScript side, we have functions that execute. In this case, it'll say, hey, is there anything in the work queue? If there is, go send it over to the ESP8266, and then take the output, and then call the callback, and then keep doing this whole operation again. So what we get is, we first, if there's something in the work queue, we go send that thing that was in the work queue. The ESP8266 receives some data. WebSockets clients actually mask their data, so there has to be some minimal processing that's done ahead of time in order to actually get a plain text message back. That's done there. And then it calls custom command, which figures out, okay, well, this is what I do with the data. And in this case, oh, it says CM. That means, well, I'm going to go send back 512 samples of that oscilloscope data. In which case, the onMessage callback gets called inside of JavaScript, which then it says, oh, well, I was currently working on that thing in the work queue, so I'm going to go call getOscope, which then updates the HTML5 canvas. And this happens all over again. Somehow, this entire operation, including calling getOscope and updating the canvas, can still operate at 200 Hertz, which is just amazing. I love WebSockets so much. Isn't it just grand?